This is Unit 1, the alphabet and grammar of geometry. Preview video 1.4, brain in hand, problem solving. Sit tall. Ready? Inhale. Hold for 3. Birthday candle 5. Ready? Inhale. Hold for 3. Exhale 5. Ready, students, you are looking at this 1.4, brain in hand problem solving. Don't forget date, time, and location, please, as well as a parent, guardian, or teacher sign off. What I'm about to go through in today's video is one of the most revolutionary approaches to understanding how your brain works and its application to math and something called your fingertips. This entire, what we're about to do is called brain in hand learning. Let me give you a little background. It's absolutely critical. Several years ago, about a decade ago, actually it's a little bit more than a decade now. It's probably 2008, 9, 10. I was finding that students were having an increasingly difficult time when I would draw a very simple problem on the board, like an angle, and it's being cut in half. This entire angle is 60, and I asked students what this was, and I got a lot of this for this rather simplistic problem. I don't know. Notice very often when I was tutoring with students is their hands were in just on their side or folded or away from the paper, away from the board, and they were not connecting with how. And I was finding myself grabbing hands and tracing on the board. This angle is 60. It's cut in half. What is this angle? And I was getting this reaction. Oh, it's 30. Like they literally didn't see it. And I started asking myself, what is going on? And the result of trying to ask that question, what is going on, was the basis of my master's thesis. So my master's thesis, finishing 2014, looked at how is digital technology changing literally the way that your brain is wiring versus you, the digital immigrant, versus, no, you are the digital native. I am the digital immigrant. How are our brains wiring differently? So I'm going to talk very briefly about how digital technology is changing the way your brain wires, as well as some key things you want to do in light of that. The first and most important thing to learn, this is what's called the frontal cortex of your brain, frontal cortex. The frontal cortex is the thinking part of your brain, the thinking part of your brain, versus this inner, the inside of your brain would be the amygdala. That's the fight or flight, instantaneous reflex part of your brain, versus back here would be your visual cortex, etc. Your frontal cortex of your brain is wired to be interactive with your fingertips, not just your eyeballs, but with your fingertips. Your frontal cortex processes information through your fingertips. That's key thought number 1. Key thought number 2, because we are using technology and replacing physicality, technology is literally reshaping how our brain's wired. And I have footnotes to all of this from my master's thesis and various books that I've read. If you're curious, you can look that up. But because we are keyboarding more than we're physically writing is superior. That's why writing in a planner, writing lists, and handwriting your essays before you type them actually is superior. Handwriting your study guides, handwriting cue cards. Because you keyboard more than you write, because we click on stuff more than we color stuff, because we're tapping on screens more than we're physically playing with models, it means our brain is wiring differently. That's key thought number 2. Key thought number 3, this is so very critical. Reading off a computer screen or a tablet screen or a cell phone screen is different than reading on printed paper. That's why in class, I'm always emphasizing printed paper. And that is because when your eyeballs hit a physical textbook or a physical piece of paper, you're more likely to systematically go left to right, line by line, which means you're going to miss stuff much less. When your eyeballs hit a tablet screen, a cell phone screen, a computer screen, our eyeballs tend to go, woo, rolling, screening, skimming all over the place, which is bad news because if you skim instead of actual line by line reading, you miss stuff. Key thought number 3. If you increase the usage of your fingers and the way you do math and model, and I'll explain exactly how to do that, it increases the function of your frontal cortex, increases the proficiency of your thinking. Physically tracing with your finger, tracing on things, drawing, physically tracing, physically drawing, physically shading, physically blocking, all of that increases the comprehension of math. In fact, there's a spot in your brain devoted to the process of visual spatial mathematics. It's behind your left ear. It's called the left angular gyrus. You can look it up. And studies show, which I am citing here in this study right here, and the footnote is down here. If you really want to look it up, you're welcome to, that as you increase the use of your fingers and making gestures with your hands and arms, it increases your perception and understanding of mathematics, especially geometry. And when you fail to use your hands, it decreases your comprehension. That is called the left angular gyrus. Those are 5 key thoughts. How does it apply to this class? You will never be paralyzed by math or science problems again if you get this one key concept. Simply this one concept. The split second you feel that I don't know feeling, I don't know, you do not fold your arms up and simply give up. I call it do the noodle. I don't know. And then you just kind of, pencil stops moving. This is super important. You do not understand first and then apply effort. That is not the order. You apply effort, which gives you understanding. Now, this is where a lot of students get tripped up. They're like, how do I apply effort if I don't even know what's going on? That was what I'm about to show you. You apply effort into doing something, and then at some point in that effort, the light bulb will go bing, and you're like, I understand. Effort first, then understanding. Effort yields understanding. Effort yields understanding. Students, if you're actually watching and following along in this video, I like you to write this word, yay, I get it. Yay, I get it. Now, verbally, I'd like you to circle the yay. Circle the yay. You don't understand first and then apply effort. How do you apply effort when you don't understand? You use this list. What you can do, when you don't know what to do? What can you do when you don't know what to do? Number one, 3 body parts. You read with 3 body parts 3 times. We've modeled this once. We're going to do more of that. You read with your finger on the paper, lips moving, eyes on text. You filter, highlight with all numbers and units. Then you draw, label, list, cross out, trace the diagram. Second thing, if you don't know what to do, you go to your reference booklet and you ask yourself, well, we're talking about angles. Where's the section on angles in my reference booklet? And you just start looking stuff up. You ask yourself, well, what can I do? Not what should I do? Get should out of your vocabulary. I call this squeeze the sponge. You find anything you can do and you do it, even if you don't understand it. Go like this with your hands. Go like this with your hands. Hands. Repeat after me. Equations have 2 sides with an equal sign. See that? I made an equal sign. Say it with me. Equations have 2 sides with an equal sign. When you write an equation, you will write all equations with 2 sides and an equal sign in the middle. And when you do equations, especially in geometry, go like this. You talk about things before you do algebra. You talk about things before you do algebra. Last, when you're working with equations, you're going to do something what I call circle, plug, chug, circle, plug, chug. I'll model all of this for you. You're now looking at this page. I highly recommend some colors, but it's not required. All right, we're going to start with something really easy here. And even though this seems really easy, I still want you to follow my method, please, okay? Step number 1, you put your finger on the paper and you read lips moving. Ready? With me, read. In. You're like, Miss Way, what happened to the sound? Nothing. You were supposed to provide the sound by reading aloud. Now, we filter. We have a segment and distance, FE. We come over here, always bracket your distances, F to E, and we already have it labeled, it's 6. F to D, 18. I come over here, F, bracket, 18 to D, 18. Find D to E. So D to E. Now, you use your fingers and go like this. Finger pinch. This is 6. Fingers on the paper. This is 18. 6, 18. ED. Here's your thing equation. I know FE plus ED equals FD. This is your thing. Things before algebra. Now we do our algebra. Circle, circle, plug it in. This is 6. Plus ED is our unknown. Equals FD, circle, plug, chug, 18. And of course you solve. Minus 6, x equals 12. I know this seems simplistic. Let's try something that's going to challenge you just a little bit more. Ready? Read aloud. All right, now we're going to focus. Our goal is to find G to D. So I'm going to bracket, question mark. Very important. Do not just use your eyeballs. Use your fingers to process the information. Ready? F to E. Put your finger on the paper. It's 12. F to D is 15. Go back. FE 12. FE, F to D 15. Remember, you do what you can do, not what you should do. So I'm ignoring that big red segment, totally ignoring it. I'm doing what I can do. 12, 15. So I just figured out that this little piece here, squiggle, is 3. How? Because my finger's on the paper. If this is 15, that's 12, 15, 12. This little missing part has to be 3. Ready? Let's see what else we can do. Put your fingers at 18. Now bring it up. Oh, that's 18 too. Let's see what we can do with that. From here to here, squiggle, 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 squiggle. I'm tracing, I'm drawing, that's 18. Pinch it, 18, 3, boom. You just found the entire thing, which is 18 plus 3, of course. And you get 21. Pinch, trace, squiggle, draw, fingers, fingers, fingers. Turn the page. Let's do, ready? Taking a look here now. I'm going to walk you through step number 1. First, you read out loud, finger on paper. Finger, not pencil, finger. Ready? Read. Should have read that out loud. Notice the sponge. The sponge means you take the diagram and you squeeze out every drop of information. When you see that sponge, I'm not going to tell you what to find. I'm going to tell you to find everything possible. And I'm not going to tell you what's possible. You have to take the diagram and find everything possible. So, step 1, let's sweep the diagram. So just with your finger, literally just trace. Straight line, trace. Oh, just kind of trace. Feel that? 90 degrees with your finger. Another straight line. All right. Now we're going to start color coding here. This is where colors come in handy, friends. Colors come in really, really handy here. There it is. So I'm going to trace. I'm going to trace this angle. Trace and sweep. If you can, switch colors. Trace and sweep. I don't tell you what to find. I say find everything. So you start asking yourself, well, what's true? What's true? Let's talk about what's true. I got a 90 degrees here. What can I find? That's 90. This is a straight line. Go like that with your finger. Can you feel that? It's half a circle. It's 180. Go like this. 180. Trace it. trace with your fingers, trace, which means squiggle, 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 squiggle. You just figured out that's 90. Let's see what else we can do here. So here's our thing equation. Ready? I have a little angle plus another little angle equals a bigger angle. So notice what I wrote. Little angle equals bigger angle. So that's our thing equation. Two little angles add up to a big angle. Now we circle, plug, chug. Little angle. One of my little angles is 61. Little angle, little angle. Big angle, trace the big angle, 90. All right, now we have an algebra problem. Let's solve for x. Listen very carefully, folks, very carefully. This is not algebra class. X is not everything. In algebra, solving for x may have been the entirety of your problem, pretty much every single time, not geometry. If you stop at x right now for this problem, you would literally get half credit. Half credit. You're like, wait, Miss Way, I solved for x. What else is there? Circle, plug, chug. Circle, plug, chug. That's 61. 9 plus 20 is 29. I just found two angles. I have two angles. Let's see what else we can find. Like this with your finger, straight line. Oh, what could I do with a straight line? Straight line, straight line. I could sweep 180. Sweep 180. Sweep with your finger, feel that. Sweep 180. Ready? Okay, go like this with your finger. Trace the 29, trace this. Keep going back and forth 2 or 3 times. 29, trace this. Squiggle angle. You see right now? With your finger, you're tracing with your finger 180. So I have this squiggle angle, if you will. Squiggle angle plus 29 equals, boom, chakalaka, 180. Solve. I just found an angle here, 151. Oh, I found another, but you didn't tell me to find that, Miss Way. You're so correct. I told you to find everything possible. Take the diagram, squeeze like you're trying to dry a sponge out, squeeze out every little piece of information possible. Let's see what else we can do. Ready? See this? See this? Let's trace it. Finger trace. Go like this from here to here. Behold, another half circle. So I'm going to dash it this time. And there to there's 180. And you can see here, I could add from here to here. I'm going to add 90 and 61. From here to here is 151. So to get this straight line finger, to get this little piece, I'm going to do 180 minus 151. Oh, wow, looky there. It's 29. I like you to shade the two 29s. They have a very special property. Just shade them. Now go like this. Trace, 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 trace. Looks like a giant bow tie. Trace, 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 trace. Do it like 3 times. These are called vertical angles. They are always going to be the same measure. 29, 29. That, my friends, is how you're going to use your fingertips to process mathematical information. We're going to do two more. You're going to get this. You have to learn to access your left angular gyrus. Things first before algebra. Put your finger here. Read aloud. Go. Notice it says all possible. Sometimes not everything will be possible. Am I going to tell you when that is? You have to figure it out. Ready? Let's do our thing equation first. Take your fingers and physically trace the entire diagram. Just literally fingers trace the diagram. Instantly you should start feeling, oh, those are bow ties. I just learned something about bow ties. Go like this with your finger. Go like that. Sweep with your finger. Half a circle. Go like this way. Also half a circle. Ready? Thing equation. I'm going to use colors here. I've got a baby angle and another baby angle. And those baby angles add up to 180 degrees. That's half a circle. How did I know that? Because I traced it. And your brain tells you, oh, half a circle. A full circle is 360. Now, we circle plug Chuck. Circle, angle, circle, and plug it in. The physical act of circling helps your eyeballs pick up the accurate information. Failure to circle means you will possibly drop some important information. Circle, plug, chug. Solve for X. Ta-da! You're not done. Be really careful with that, friends. This is not algebra. Just because you solve for X does not mean you're done. I didn't tell you to solve for X only. Obviously, I tell you solve for X and then find all possible angles. All possible. Ready? Let's plug it in here. This goes in here. I'm going to go 6 times 21. Okay. Plus 3. So I just found this angle here is 129. And finger, straight line, that's 180. And if I do 180 minus 129, you know that you're going to get 51 over here. And again, right here, I go like this with your fingers, trace it. That's 180 again. 180 minus 51, we already did the math here. 129. Trace, 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 trace. Bow tie angles are always equal. Trace, 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 trace. The bow tie angles are always equal. The fancy name for those bow tie angles are called vertical angles. We'll come back to more of that in just a little bit. Ready? Let's do another one. This one you're doing on your own. Pause the video. Follow my instructions. Restart when you're done. Pause the video. Welcome back. You should have a red pen handy, and now you're correcting. Your equation was this. An angle plus another angle equals now 360. So you should have had 50 plus x plus 37 plus the 228 equals the entire circle, which is 360. You solve for x, you get 45. You're not done. Plug in the 45, 82 here, 228, 50, 228, 82, 50. Add it up, 360, check. You're done and accurate. Now let's apply what we just learned to some geometry problems. Couple things, we're going to work just with rectangles only because they're pretty simplistic. And in a rectangle, I'd like you to label it. We have 2 lengths, 2 widths. Perimeter, always trace around with your finger. Perimeter is like a picket fence. Perimeter, picket fence, always trace around. When you do perimeter, I want you to walk your pencil around like this, put a little arrow there. That represents I went around. So a perimeter is simply going to be length plus width plus length plus width. That's for a rectangle. Now, in the past, you have probably done something like this. Perimeter equals 2 lengths plus 2 widths. I personally will never use that. It leads to too many errors. I prefer you just to walk it around. Length plus width, length plus width. That's your perimeter. Picket fence. Grass. Area is like the grass of a yard. And when you do area, always get in the habit of shading. Shade, shade, shade. That tells your brain that you're dealing with 2 dimensions. Perimeter is length around. So when you're dealing with perimeter, you're dealing with singular units, centimeters, inches, feet. When you're dealing with area, it's 2 dimensions. Keep in mind, centimeters squared, inches squared, feet squared. Area of a rectangle, of course, is simply length times width. That's what we're going to be using. Before we do the next 2 problems, let's clarify this really simple concept. I'm going to wait 10 seconds and see if you can't fill that out by yourself. X plus X, X times X. Do not mix those up. We're going to do 2 problems. I'm going to do 1, then you're going to do 1, and we'll be done here. I know it's a little bit longer than usual, but it's really, really, really critical to how we learn in this class. We're going to start by reading with 3 body parts 3 times. Finger on paper, not pencil. Finger. Ready? Lips moving. Read. Now we filter. We're going to underline keywords. The perimeter of the rectangle PQRS, 26 centimeters. Longer side PQ, 3 centimeters longer than QR. Find the area. Now, you're like, I don't know what to do. Great. That is what this is for, my friends. So now we draw a label list. cross out. No naked diagrams. We are told that the longer side is PQ. So I'm going to start with P here, Q. I'm going to go clockwise, R and S. What are we told about this? The perimeter. Physically trace the perimeter. Physically trace the perimeter. We are told that is 26 cm. Cross it out, cross it out. The longer side, PQ, label, length, width. The longer side is, that's an equal sign, 3 centimeters longer than the width. Longer than, that's a plus concept. So the width plus 3 centimeters. So the length is whatever the width is plus 3 centimeters. We are being asked to find area. So just stripe it. Area equals question mark. You're like, I have no clue how to do this. Perfectly fine. Don't give up. So when you don't know what to do, you do what you can do. Let me model. Like, I don't know how to find the area. You don't start with what you want. You start with what you have. Don't start with what you want. You start with what you have. I have perimeter. What could be something I easily can do? Well, I could write down my perimeter equation, can I? That's easy. Equals length plus width plus length plus width. Those are all pluses. There we go. I don't know what to do with it, but I can write it down. I want area. I can at least write down that equation, can I? Yep, I can do that. Well, obviously for area, I need the length and the width. So you don't start with what you want. You start with what you have. You're only given one piece of information here, really. 26. That's called circle, plug, chug. Notice I circled, I plugged it in. Length, circled, plug it in. Width, circled, plug it in. Length, circled, plug it in. Width, circled, plug it in. Circle, plug, chug. Let's see what we can do with this now. We're down to one variable, friends. Ready? Ta-da! You just solved for a variable. Congratulations. You're not done. You just found for the W. Now your length is going to be, of course, 5 plus 3. So the length is 8. Down here, now we can circle, plug, chug. Area, length, plug it in. 8. Width, 5. Parentheses. Area equals 40. You're wrong. Careful. Not exactly wrong. I would say incomplete. If there are units in your problem, there's units in your answer. The answer here is centimeters squared. Now you are done. Last page, do this on your own. Walk through the process, finger track, read out loud, pause the video. All right, welcome back. So you should have traced, you're looking for your perimeter. Twice the width, you had 2W here. Let me give you a tour. You start with what you have, which was area. Area equals 450 centimeters squared. Area equals length times width. 450 equals 2W plus W. Why? We swapped out the length with 2W. W times W is W squared. 2W squared equals 450. Divide by 2. 225 equals W squared. Opposite of squaring is square rooting. And the square root of 225 is 15. The length is twice that, 30. So you go, walk it around. Right here, you go 30 plus 15 plus 30 plus 15, and perimeter is 90 units centimeters squared. Big star smiley, what you did correct. Write yourself a note about what you want to remember next time. Summarize the main key concepts of today's lesson.